Hello, everyone. Welcome back to SAT Math Question of the Day. Here's our question of the day. Um, okay, and at the end of this video, we are going to give some advice on other resources besides ours. So if you want to just skip to that, go to the end of the video. Okay, here we go. 3 times the quantity in parentheses, kx plus 13, close parentheses, is equal to 48 over 17x plus 36. In the given equation, k is a constant. The equation has no solution. What is the value of k? So in order to have no solution, the coefficients on the right and left-hand side of the equation, the coefficients of x on the left and right-hand side of the equation have got to be the same. So all we have to do is just set the coefficients to be the same, which I just have to annotate here, is, yes, that's doing it. 3k has to equal 48, Seth and I are doing it together, over 17, and you just solve for k at that point. And you should simplify your solution. So the answer is 48 divided by the quantity of 3 times 17. Seth is doing it. It's 16 divided by 17. Problem solved. The question I have is, why do the SAT people, because this comes from an SAT educator site, which, by the way, could appear on Blue Book. That was a little spoiler there. Why do they make this a difficult question? Because you just have to know this one idea, and it's a one-step question. I do not know why they labeled this as difficult, but that is the answer. And because they say it has no solution, you don't have to worry about the coefficients of 39 and 36. But the coefficients, the constant terms, not the coefficients, the constant terms on both sides of the equation have to be different, and the coefficients of the x terms have to be the same in order for it to have no solution.
Well, when you have some coefficient times x,
yep,
on the left-hand side, and the same coefficient times x on the right-hand side, and the rest of the two sides are two constants, b1 and b2.
Yep.
Well, this equation is equivalent to the one obtained by canceling out the ax. So this equation is equivalent to the equation that says two constants are equal. Well, when two constants are equal for all x, when the two constants are the same.
Right.
And so when the two constants are the same, it has infinitely many solutions. Every value for x is a solution.
Yeah.
When the two constants a and b are b1 and b2 are different, then there's no solution.
Right.
Because the equation is never true.
That's right. 3x plus
So that's the principle. So they're telling you in this situation, there's no solution. And the only way there could be no solution, no solution means that the coefficients of the x's are the same, and the constants are different.
Right. Yeah, we already said all this. Yeah.
So we could what they gave is consistent with having no solution.
Yeah. Yeah. Absolutely. Yeah.
So
yeah.
They could have asked. Well, they could have made the constants. They could have involved an unknown a constant for within one of the constants, and then you could say what the two different constants are for it to have no solution. Yeah. You say any number would give. Of course, you'd have to, if they ask for what constant does it have no solution. Well, then there are infinitely many choices.
Yeah, but they didn't do that.
They could give no solution.
We didn't do that, so let's not confuse people.
They didn't ask that.
They didn't do that. Yeah, so let's not confuse people.
So these SAT questions do not expose you to the whole story.
Yes, that's right, because well, sometimes they do. Sometimes they do, but this one absolutely did not. So let's ask our little 4 questions. First of all, can you start with the guess? Of course not, because it's free response. calculator, there's probably some clever way to do this with a calculator, but it'd be completely impractical. And we could talk about that a little later, actually. It has this different from a school test. Yeah, maybe it could be. You could see this as a possible question on a school test, particularly if the teacher uses this resource to help people in algebra. And what is there a pattern to this question? Particular numbers of this question that make it fall out easier? No, not really. And the main idea
except that 48 is divisible by 3.
Nah, it's not really a pattern.
Just
but yes, that makes it a little bit easier to simplify. That does make it easier to simplify. Yeah. And they are going to want you to answer this as a fraction, not as a decimal. I'm sure the decimal answer would not be acceptable because it's a repeating. It's got to be a repeating decimal. It's rational. It's rational, so it's got to be a repeating decimal. But who knows how many digits it could repeat on? Maybe 16 digits. I don't know. Probably no more than that. And any questions? And then what's the main idea of this question? What are they trying to see if you know how to do? And we really talked about it. If you have a linear equation with x's on both sides, you need to know under what conditions is there one solution, under what conditions is there no solution, and under what conditions are there infinitely many solutions. And we already talked about those conditions. So let's see how they did it. We will clear all drawings. Stop this thing. Oops. Sorry about that. Okay. And then go like this. And here we go. Interesting. They're allowed a decimal answer. Wow. Whoa, look at that. That's a big surprise. But anyway, 16/7 is
of
really
course, if you actually use that decimal, it would have one solution. Because that decimal is not exactly equal to 16/17.
Yeah, I know. I just don't understand how.
Stupid.
I don't see how those can be acceptable answers. And not only that, but they're both.
Yeah.
I just don't get it. Whatever you do, do not do that. Don't take a chance on the SAT. Don't tempt them. Give them fractions. Fractions, I always say, when you're in high school, fractions are your friend. When you're in middle school, you want to stay away from fractions because you have to add and subtraction, which is a pain. But in high school, fractions are your friend. Okay, anyway, so they go here, no, a linear equation, ax, whatever, ax plus b, c plus d, has no solution with the coefficients at each side the same. So we did it exactly the way they did it, except whatever you do, stay away from decimals. Decimals are great when you're comparing fractional things, but in a problem like this, no, it is not. So, let's see. I'm Joel. I have let's talk about ourselves a little bit. Introduce ourselves. I'm Joel. I have a PhD in mechanical engineering. My brother has a PhD in math. He always takes the more theoretical approach, which is good. And trained as an engineer, I try to just get the answer done as soon as possible. And we try to meet once a day to give a question a day. Now we're working on the SAT educator site. And we try to offer different ways to approach the problems. We've merged very much into what is the main idea, because while we don't know exactly the question you're going to get, we know these ideas, these concepts behind these questions are going to appear on your test. And to practice for the SAT, take all the Blue Book tests. And we've heard rumors that Blue Book 4 and 6 are the closest to the actual SAT, on the math side at least, so make sure you pay attention to those. If you want to brush up on any one particular topic, go to Khan Academy. They offer a digital site that is sanctioned by the SAT. They partner together, so do the questions on the topics that you are weak on. Also do the questions on topics you're strong on, so you can do them blitzingly fast, if that's a word, to make sure you get those done as fast as possible to have time for those hard questions. Now, talking about those hard questions, we've found that you can do all the Khan Academy questions you want. The SAT throws in about 1 or 2 questions on Module 1, and if you're lucky enough to get to Module 2, about 4 or 5 questions on Module 2 that the Khan Academy does not prepare you for. They seem to be much harder than anything that you would ever see on the Khan Academy. So what do you do? How do you practice for those questions? Not us, because we don't have the capabilities and the time to make up questions that clever. But we've found a resource on the internet that can help you. So I'm just going to share these resources. These guys, they seem to have it right. I assume they're guys. These guys have it right. You could buy this course, or you could buy 150 questions that really feel like those really hard questions. Is a great resource to practice if you want to see how to do those super hard questions. Also, something we strongly suggest is go to YouTube and watch a few videos on how to use Desmos. And some of these videos are some of these examples are horrible. They'll use Desmos for a question that has no business using Desmos. But some of these techniques are very useful. You should know Desmos like the back of your hand and fluently heading into this digital SAT, because there are some questions that Desmos is a game changer on. So watch a bunch of these things and practice with those. Okay, so if you have any please comment on our videos. Please like, dislike any our videos. Any comments are very welcome. We try to respond to everything. And if you have any SAT math questions you'd like us to go over, please email them to us at satmathquestionoftheday@gmail.com. Okay, anything else, Seth?
No.
I think we're done for today. Okay, everyone. Have a great day. Take care. Bye-bye.
Okay.